Hi all, last video for this section. We're going to talk about De Morgan's laws, but first, something even more important, which is, which do you like better, Pepsi or Coke? Everyone always has an opinion about this, including me. I hate them both. So I don't like Pepsi and I don't like Coke. I do not like either Coke or Pepsi, it's true. I hate the sugar. If I really can't find coffee, I'll drink one of them out of desperation. But I don't really like the diet stuff either. Ugh, I do not like Coke and I do not like Pepsi. And here you thought this was going to be about De Morgan's laws, right? But it is actually. So I want you to look at what happened to my words there. I do not like Coke or Pepsi, right? So not, and then an or. But here it's I do not like Coke and I do not like Pepsi. It's true, I don't. I hate them. Ugh, they taste vile. I don't know how you guys can drink them. And energy drinks, let's not even go there. But anyway, let's focus on not and or, and then not and another not. So we can write this symbolically like this. I do not like either Coke or Pepsi. Looks like this. Coke or, because or is union, right? Pepsi with a not symbol. And then here, not Coke and not Pepsi. So remember the intersection symbol? That's the intersection, that means and. And so this is an example of what's called De Morgan's laws. And officially it's usually done with A and B instead of Coke and Pepsi, just generic sets. And look at what happens to the union symbol, right? The union symbol turns upside down and becomes an intersection. And here, the intersection symbol turns upside down and becomes a union. And this not gets distributed to both parts of this. So it starts out on the outside and then gets distributed just like when you distribute the negative sign. When it's outside parentheses, it's the same idea. Remember this guy, by the way? This is Augustus De Morgan from our problem-solving unit, who tortured us all by saying I was X years old in the year X squared. Actually, I really love that problem. He really was an actual mathematician who actually lived in the 1800s. Pretty awesome. So let's use this De Morgan's laws to rewrite this. And then after we've rewritten it, just following our example, try to translate it into words. So pause the video and try this. Really pause it. Really try it before you go on. So I'll wait. Okay, hopefully you paused the video and now you're ready. You wrote down your answer, your ideas, you translated into words. If you didn't, pause the video now. And now here we go. So you notice here that the union becomes an intersection and that this not symbol goes to each one of these. And in words, the first one is food that's not liked by mom or kid two. One not and an or. Food that's not liked by mom or kid two. And it becomes food that mom doesn't like and kid two does not like, right? Okay. Instead of doesn't, you can say does not. Make sure you get the not in there, but it's the same idea. And you see that the or becomes an and that once there was one not, you now get two nots. So in our Venn diagram, I want to show you where we found mom union kid two not. We did that by doing mom union kid two, right? That's the food mom or kid two likes, all of that. And then the not, that's the complement, is this purple area. I just colored it in purple so you could for sure see that that's the not. So I want to show you how that comes out just like this, right? How you end up seeing that this, with the not on the outside, turns out to be the same colored in region as this. So let's try it out. So this is the first one. Mom union kid two with a complement on the outside. So let's find this one. Mom not intersect kid two not. So first we find everything mom does not like on this diagram. That's everything that's not this green circle, right? All this pink part. So that's the food mom does not like. That's not M. And you can always also write down the regions if you don't feel like coloring. I just like coloring because it really gives you a good visual and it's more fun. So then the next thing is step 2, find not kid 2. That's everything kid 2 does not like. So here's kid 2, right? And I colored everything kid 2 does not like in orange. It's all of this stuff here. And if you want, instead, you could just write, that's the regions 1, 2, 3, and 8. Now the question is, what's the overlap of those two pictures? It's what was colored in both pink and orange. So, this is going to scroll back and forth between these two things. So here's the part that we colored in here, right? Nope, sorry. Here's the part we colored in here in pink. That's not mom. And we want to overlap it with the part we colored in orange. That's not kid 2. And you know what? It's really hard to figure out. What did we color both colors with, unless you have the pictures side by side? So maybe I can just shrink them a little bit, make the pictures be side by side. I'm not sure. Yep, so here they are shrunk down side by side. So you can see here's not mom. And here is not kid 2. What did I color both places? I colored region 1 both times, right? And what else did I color both times? The only other thing I see that I colored both times is region 8. So it might be easier to list them by region because then that's easier to see. But I think that it's more fun to color. I just do. And so you can see that those are the colored regions that got colored both times are regions 1 and region 8. But guess what? That's the same as the regions we got here. This is region 1 and this is region 8 right here. It's the same as the union, the complement of that union. So maybe that's a little hard to take in one go. And that's why on your project, you'll have more figuring out how De Morgan's laws work and why this is the one that's equal. These two are equal to each other. So I'll see you in the video about the project if that's what you want to watch next. There's a video for that too. Or better yet, stop watching videos and do some homework. See you later. Bye.